Once again, good morning to all. So in today's session, we are going to discussing about direct communication. So this is the sub-concept of inter-process communication. So in inter-process communication, it was discussed there are two approaches. One is the message passing, and another one is the shared or shared cooperation. Yeah. So one is inter-process communication and one is message passing and another one is the shared memory. So these are the two approaches was used in the inter-process communication. So already we have discussed about what is shared and what is message passing. So in this session we are going to discussing about what is meant by direct communication and what is meant by indirect communication. After that we will discuss several examples like how to implement IPC in Windows platform or either batch, any others. So these are the concepts we will try to discussing in today's session. So coming to the first one, direct communication. So here whenever we are going to establishing a communication or providing a communication directly, so that means there are, for example, there are two nodes like node A and node B or node P and node Q. So now if you want to provide the communication among those two nodes, we want to communicate, communicate among those two nodes. So for that purpose, so here directly node P can send some message to the node Q and node Q can receive the message from node P. At the same way, node Q can send some message to node P. At the same way, node P can receive the message from the node Q. So for that purpose, it was using majorly two keywords or two commands, that is send and receive. So this is the syntax for sending a message and receiving a message. So here to send a message we are using the command that is send. So and their arguments is this particular message was send to which node. So in case process P wants to send some message to node Q or process Q wants to receive some message or send some message to the node P. So at that time it will mention, so this particular message was sent to which node and what is the message. So that is here node Q wants to send some message to node P. So that's why here that particular message was sent to node P. That's why here we mention node P process name or node name, and then what are the message we want to send. So in this way we are sending the message to the node P. At the same way, whenever node Q want to receive some message, node P wants to receive some message from the Q. So for that purpose it was send us some message with the help of this keyword this command, that is receive. So here node P wants to receive some message from where node Q. It receives message from node Q. So that's why here Q comma whatever the message. So it indicates which here it receives a message from the process Q. So in this way here directly two or more nodes can be communicated. So in this process where we are going to implementing the direct communication, so in this process what are the several properties of the particular communication link? So here what is meant by link? First of all, here link is simply connection between those two processes. Here link is some connection between those two processes. So with the help of this link, those two processes can share some information, either sending some information or receives some information. So for that purpose it needs some medium. So that medium is nothing but link, which may be cable or it may be wired or wireless. So that's why, so when we are going to establishing the direct communication, so for that purpose first of all we must establish the link. So here link establishment means nothing but providing the connection among those two processes. So this connection establishment was implemented automatically or provided automatically. So that means each and every time those processes doesn't need to create or to establish the link from one process to the another process. So this responsibility is handled by the operating system. So here operating system is responsible for providing the communication links are establishing the link among those two processes. And next here, a link is associated with exactly one pair of communicating processes. Why? Because here each and every link or in this communication we are implementing direct communication. We are implementing the direct communication. That means those two processes can have exactly or can have some dedicated part. So to send or receive messages, for that purpose those two processes having the some dedicated link or dedicated path. So here dedicated link means nothing but so that particular link or the particular path is only used for transferring the data among those two processes only. For example, there are P and Q, these two are the processes. Here dedicated link means nothing but to send the data from or to send a message from node P to node Q or node Q to node P. So both are using the some specific link only. So that is a dedicated. So here while we are going to establishing some link for direct communication, so that particular link is exactly established among those pair, that means those two nodes only. So here just now we discussed among two communication among two processes communication exactly one link was used. Why sir, why we are using only one link, why we can't use more than one link means in case we are using the more than one link or more than one path among two processes, then what is the problem? When we want to send some message or receive some message, then we choose which path. So which path is the better to send the message or which path is the better to receive the message. So for that purpose it needs some processing. So it takes some more time. So that's why always we are trying to maintain some dedicated and unique path among the each pair of the processes. Here which type of link was used in direct communication? So we may be use either unidirectional or we may be use either bidirectional. So what is meant by unidirectional and what is meant by bidirectional means already you know very well about this one. So that is nothing but half duplex and full duplex. What is meant by half duplex? Actually that particular link or that particular communication channel have the capability of sending the message from node P to node Q, at the same way node Q to node P. So what is the meaning of that one? It will send a message. For example, there are two nodes or two processes A and B. So now we want to send some message from process A to B or process B to A. So that communication channel is the capable of sending a message from A to B and B to A. But at a time only one way can be allowed, either node process A to process B or process B to process A only. So that is the half duplex. Simple example for half duplex in communications, not in operating systems. So in communications is walkie-talkies. So here at a time it was send a message from either one person to another person only, and simultaneously we can't able to exchange the voice information among those two persons. So that is the simple example for the unidirection. So at the first person one was wants to say something, so he will say that particular message, that particular voice. After completion of that one only, receiving person can react or send some another message to the person one. So in this manner, at a time only one person message or one person data can be transmitted through the particular link. So such kind of links is known as the unidirectional, or your terminology is the half duplex. And coming to the full duplex, so this is simply it can able to transfer the data among both directions, from sender to the receiver or receiver to the sender. Otherwise process A to the process B to the process A. So in both directions it can able to send. So such capable of link is known as the bidirectional or full duplex link. Next, so these are the few details about the direct communication. So in direct communication we are using only two commands, one is the send, another one is the receive, and here what are the properties for link. Now coming to the indirect communication. So, first of all, we observe what is direct communication, what is indirect communication. So, in direct communication, for example, if I want to say something to you, so directly I will say something to you without any third party or without any third person. So, directly I say something to you, so without any other person. So, that is direct communication. So here indirect communication means so in between the sender and receiver or in between the process A and process B, we are using one more process. We are using one more process. So this middle process responsibility is whenever process A was sent some information, it stores that information up to where whenever process B is available. Once process B is available, immediately it will forward such information to the process B. That is the responsibility of middle person, third party. At the same way, whenever process B wants to send something, some information or some data to the process A, then so it will not directly forward it to the node A or process A. So it will send such information to the process A mailbox. Now process A can check their mailbox for getting any information or any data was received or not. So in this way, so that is the indirect communication. So here messages are directed, but those are received from the mailboxes. So these mailboxes is also known as the port.
Income tax చేయాలా బయట
Sorry,
లింక్ యాక్సెప్ట్ ఉంది మీన్స్ బయట వెయిట్ చేస్తుంది
హలో చేయమని ఆటో అడ్మిట్ ఉంది కదమ్మా. Okay, so these are the some basic differences between the direct and indirect communication. So in direct communication, directly sending the message to the receiver process. In indirect communication, whatever the message want to exchange, so whatever the message want to send, so the particular message was first of all sent to the they related that particular process related mailbox. So that means while we are going to establishing or processing, so while we are going to processing indirect communication, at that time, so at that time, sorry, so while we are going to implementing the indirect communication, so in this process, so whatever the information we want to share with another process, that information doesn't directly send to the that another process. So in between we are using the some another process, so that is the some mailbox. So whatever the information we want to share, so such information is shared with the third party node, so that is the mailbox. So here how that particular receive node can access that mailbox information means, so for example I want to send some information to either 501, so okay, otherwise 5E0. So in this, so in case I was using direct communication, directly here operating system is responsible for establishing a link or path between the myself and 5D0 or 5E0. So and then I will send such whatever information I want to share, so that entire information can be forwarded to the 5E0. So in case either 5E0 or 501 wants to share something to me, so then directly send some information to the same link. So this is the process in direct communication. So coming to the indirect communication, whenever I want to share some information with 501 or 561, so 565, so at that situation, so I will send that particular message to 501's mailbox, 501 related mailbox. So whenever 501 coming to the process or coming to the execution, it will check their mailbox for updates, like any information was received from anywhere or anything else, so such for that purpose. So this is the process in behind indirect communication. So for that purpose, each and every mailbox was having some unique mail ID. So why? Because whenever we want to send some information in indirect communication manner, we must differentiate. So each and every client or each and every process. That's why each and every process was maintaining some unique mail IDs. So here to communicate among those two processes, we can use only those mailbox only. So we can communicate in the processes. Those two or more processes can communicate through their mailboxes only. So now we observe what are the properties of communication links in indirect communication. So here link was established. So only whenever that particular process wants to share some mailbox, then only your link was established. But in direct communication, always that link is available. But in indirect communication, for example, when now I want to share something with the process B, myself process A, I want to share something with process B. At that time only link was established. After completion of that one, automatically that link was terminated. So in this manner. So here the particular link may be associated with many processes. So that means here whenever some communication link was established in indirect communication, so by using that link, more than two processes can exchange their information. But in direct communication, only those two nodes, only those two processes only exchanging information. Here each pair of processes may share several communication links. So here whenever one pair of processes wants to share some information for that purpose, in indirect communication those are using the multiple links, not only a single link. So here also the particular link may be either directional or unidirectional or bidirectional. That means either half duplex or full duplex. So these are the several properties of the communication links in indirect communication. So now we observe what are the several operations can perform in indirect communication. What are the operations can perform in direct communication? Only two, that is either send or receive. But coming to the indirect communication, so here we are using totally three operations. One is the creating the mailbox and destroying the mailbox and send or receiving the messages through those mailbox. So these are the several operations are used in indirect communication. So in direct communication, directly we are send or receive. But in indirect, we are using some mailbox. That's why whenever we want to send some information to process B, so at that situation, so first of all we create some mailbox for the particular process. And then we are sending the message or receiving the messages. After completion of such transmission, such data transfer, so we can release that particular connection. That means we can destroy that particular mailbox. So these are the operations. So for that purpose, we are using the several primitives like send and receive. So here send primitive is used for send a message to some process, and receive primitive is used for receive some message from some specific process. So now we observe how mailbox was sharing in indirect communication. So for example, there are three processes, process 1, process 2 and process 3. Those three processes are sharing some mailbox A. So that means either process 1 can send a message and process 2 and 3 can receive the message. Otherwise, either process 2 sending the message, then process 1 and 3 was receiving the message. Either process 3 was sending the message, then process 1 and 2 are receiving the message. Otherwise, either process 1 and 2 both are sending the message to process 3. Either process 1 and 3 both are receiving the messages from process 3. So in this manner. So how in this process, whenever process A was sending the message or process B was sending the message, then exactly the particular message was received by which process. So that is the design issue in indirect communication. So to solve such one, the possible solutions is a link can be allowed, a link to be associated with at most two processes only. So actually in indirect communication, a link can be associated with any number of processes, but to avoiding the congestions or to avoiding the difficulties in indirect communication, so we can restricting the something, we can providing the some we are implementing the some restrictions. Those are that particular link can allows the communication at most two processes only, and it can allows only one process at a time to execute a receive operation. So that means whenever we are using the indirect communication at that situation, so here it can support at a time only one node can receive the message, or only one node receives the messages from the mailboxes. And it was also allows the system to select arbitrarily the receiver, and the sender is notified who is the receiver was. So that means in indirect communication, so we can implement that indirect communication in which manner means so at the time of sending the message, so at that particular time, so that particular sender was clearly mentioned who was the receiver, clearly mentioned who was the receiver. So and whenever we are receiving the message as a receiver, what is our responsibility means we clearly receive only messages belongs to ourselves only. So these are the possible solutions to avoiding the difficulties in indirect communication. And next one is the synchronization. So now we discuss what is meant by synchronization in IPC, inter-process communication. So whenever we are passing the messages, whenever we are passing the messages in inter-process communication, so in this process basically we are using two types of messages. Those are either blocking message or non-blocking message. So those are blocking message or non-blocking message. So here blocking message means nothing but this blocking message can be considered as the synchronous, and non-blocking is asynchronous. So here what is meant by synchronous or what is meant by blocking means whenever sender was sending the message, at that time that particular sender was blocks that particular node or that particular process until that particular message was received by the receiver. For example, I want to send some message to process B, myself process A. So in this process, in case I was using synchronization process or blocking process, so how I am sending the message means whenever I am sending the message to process B at that time, so I am block my entire process until that particular message was received by the process B. At the same way, in case I was receiving a message from process B, at that time process B was blocks that particular communication link, the particular communication until that particular message was received by myself. So this is nothing but blocking send and blocking receive. And what is meant by non-blocking means, so here non-blocking is also called as the asynchronous. So here non-blocking means nothing but whenever sending the message at that time, so it doesn't block anyone. So it will continuously allows any other processes communication also. At the same way receive is also. So in this process it will check either some specific message is either valid message or not, otherwise some null message. So in non-blocking method we are using only two kinds of things. One is the valid message or null messages. So here in non-blocking or blocking messages, synchronous or asynchronizations, so there are different combinations are available. So that means both send and receives are blocking. So in especially in synchronous, in case both are blocking, that situation is called as the rendezvous. So now we discuss next one is next concept, buffering. So what is meant by buffering? So here generally buffering means nothing but some queue or some list of so here generally buffering means nothing but some list of messages was waiting for the sending or receiving. So that means, for example, I want to send some information to you. I want to send some information to you. So at that situation here, buffering means whatever the information I want to share. So such entire information was stored in the some memory. So that particular memory, that particular data is available in such memory up to which time means until you will receive the particular data or that particular information. After you have received such entire information, that particular memory can release that information from the buffer. So by simply it is some queue of messages attached to the some specific link. So here this buffering can be implemented majorly in three ways. So one is the zero capacity, and another one is the bounded capacity, another one is the unbounded capacity. So there are three methods or three techniques to implementing the buffer. So those are zero capacity, bounded capacity, unbounded capacity. So here it's very simple. Here zero capacity means there was no messages are queued on the link. What is the meaning of that one? So for example, whenever I want to send some messages to you, so here I was used buffering mechanism with which technique? Zero capacity technique. So that means whatever the information, whatever the data I want to share with you, so such data is not not waiting on the particular memory. So that means whatever the information I want to send, so that information was directly received by the receiver node without any delays. So that is nothing but zero capacity. So here there was no messages are queued on a link. Whenever sender was send a message, that particular message directly received by the receiver node. So that means here both nodes, sender and receiver, both are blocking the particular link until sender was blocked until sending a message. Receiver was blocked until receiving a message. And next, bounded capacity. So here bounded capacity means nothing but some limit. So that means by simply here sender and receiver was using some size of the buffer, either 10 MB, just assume. So here sender was using the 10 MB buffer size and receiver was also using the 10 MB buffer size. So here how we are transferring the data in buffering in bounded capacity technique means that at a time sender was sending 10 MB of data and wait for releasing the particular buffer. So whenever such buffer memory is free, again send 10 MB of data and wait until such message, such data was received by the receiver. So in this manner. So that is the bounded capacity. So based on this, you can simply guess what is the unbounded capacity. There was no limit. Bounded capacity is some finite length of data only is transmitted at a time. But in unbounded, there was no limit. Infinite length of buffer is available. So that's why we can continuously sending the data without any interruptions. So these are the three approaches was used in buffering. So now we observe several examples for the IPC, inter-process communication. So first of all, we observe MAC. So in MAC communication, so every data is transmitted in the form of messages only. So that means either we are using any system call. So even though that system call is also communicated in the form of messages. And so here whenever we are getting some task, that means some specific process, so that is also in the form of messages only. So that means it was creating some mailbox and for both the kernel and the user mode. So that means here whenever we want to execute whenever we want to process something, so for that purpose we are using the mailboxes, that means indirect communication. So previous one is the direct communication system calls. So here while we are going to implementing the IPC in MAC, so we are using the majorly three system calls. Those are send, receive and RPC. So message sending, message receiving and message RPC. So here RPC means nothing but remote procedure call. We will discuss later what is meant by RPC. So here this in IPC system for Mac, so it was very flexible for sending the messages and receiving the messages. Why? Because here we are using the four options. Those are wait indefinitely, wait at most some milliseconds, return immediately, temporarily catch a message. So with the help of these four techniques, we can easily send and receive the messages. So here wait indefinitely means so it will wait any amount of time, so any time, so not only some fixed time, so it can wait continuously until getting the some message. Wait at most some milliseconds means it can wait for sending the message or receiving the message at most some number of milliseconds, either 10 milliseconds, 100 milliseconds in this way. Return immediately, whenever we are getting some message, immediately send a response to the sending process, and temporarily catch your message. So that means in case any messages was temporarily not sent by the sender or receiver, then it will check is there any messages was available on the cache memory, then it will take such information from the cache memory. So now we observe how to implement the IPC in Windows platform. So here in Windows platform, here messages was sending in some specific facility. So that is the advanced local procedure call facility. So just now we was discussed. So while we are implementing the IPC, we are majorly using three commands. So that is message send, message receive, and RPC, remote procedure call. At the same way here we are using the local procedure call. So that means that particular local procedure call can work only between the processes among the same system. So here if you want to share some information within the system, then only we are using local procedure call. So in case if you want to share some messages or some information with among the remote, so that means globally, then that system is known as the remote procedure call. So in this process, while we are going to implementing IPC in Windows, we must use some mailboxes. So those mailboxes was uniquely identified with some port number. And here communication can be worked in the following manner. So that is here first of all the client can open the some handle. So here handle is responsible for handling the either sending messages or receiving messages. So it first of all here client was open some handle sub process or subsystem. So which is responsible for establishing the connection to the some specific port. So after that the client was sending the connection request. So now the connection request was received by the server. So then that particular server was creates the two private communication ports. So whenever server was receives the request from the client, then it will create the two ports. So those two ports was used for providing communication among those two nodes. So after that the client and server can use the corresponding port numbers to handle or to send and receive the messages. So this is the process of implementing the IPC in Windows. So here we can observe. So this is the client node and this is the server node. So whenever client wants to getting some information from the server at the further purpose, first of all it was sending the connection request. So this connection request was forward to the connection port. This connection port is responsible for establishing the connection from client node to the server node. So once the connection was established, then it was communicates with the client communication port. So it is responsible for getting whatever the request was processed by the client. So that particular process was that particular request was forwarded to the server. Now server was handling that particular process and getting some result. That result was our output. That output was forwarded to the client node. So this is the process of implementing the local procedure calls in Windows platform. So these are the few details about direct communication, indirect communication, buffering, and how we are implementing the IPC, inter-process communication, in different platforms. Next session we can discuss client server architecture in detail.